There are three common factors when building software: a user interface or what is seen by the user, data, and logic to process the data. Let's say you have a task manager app where you fill in data about your tasks, such as task name, starting and completion date, and status. When you hit the Add or Submit button, there's a business logic to validate and save your data to the database, which is called controller. There's also the model, which deals with the data part. It defines the data structure, and it's responsible for interaction with the database. Those three important entities form MVC, or Model View Controller Architecture. The controller sits between the view and the model to exchange data and to command them what to do. If the request is, for example, /uncompleted tasks, it communicates with the model to return incompleted tasks to the view, and then the view can show a list of incompleted tasks in an appealing manner to the user. So why MVC? Working with MVC has different benefits, such as the code becomes easy to maintain since each component, meaning the model, view, and controller, focuses on specific aspects of the application, making it easier to locate and fix bugs, or make enhancements without affecting other parts of the system. It reduces complexity by breaking an application into 3 interconnected components with distinct responsibilities. MVC supports collaborative development. Different team members can work on different components simultaneously. It creates a separation of concern, and it also promotes faster development by providing a structured approach to building applications. In this video, I will take a file containing a lot of code dumped into it into clean, reusable, and structured code. So we'll start creating an MVC boilerplate code, which improves this code. Here, I have an Express server with 2 APIs to create and get blocks, and you can see that everything is contained in a single file. Let me run it. Okay, it works like a charm. So now I'll take this and create a very structured architecture, like a boilerplate that we can use over every project. But before that, let me explain the code a bit. So here, I'm using Mongoose for the database, and it's connecting to the blog app database. And here, I created a schema called blog schema, which has a title and description that define the structure of the table. Down here, I created the model to interact with the database, create, and get blogs. And I also added express.json to parse the request data. And here, I created 2 APIs. One is get blogs, which is just finding all the blogs it can get from the database, and it will return it as a JSON. Down here, I have a post route to create blogs, and I just pass the request body. So I will take all this and structure it into different directories that we will use as a boilerplate in the future. We will add multiple directories, but let's start by adding the model directory first, and let me add blog model.js file. So I just created a model as I discussed in the MVC introduction. This is for the database schema and anything related to the DB. Let me take the schema to the model. So I will cut this and paste it in the blog file. Now let me export the blog model using the exports object and assign it the blog model. Let's go to the index file and import the blog model. Const blog is equal to require and pass to it blog model path. Let me save the changes and restart the server. I think I forgot to import Mongoose in the blog model. So let me copy this import statement and paste it here. Let's test it again. Okay, now it's working perfectly. Next, let's go to the index file and work on the controllers. This is the business logic part where we process and deliver user requests, which can be moved to a controller directory. We need to create the controller directory first, and inside it, let's create a blog controller file to write all the blog-related functionalities. Let me head to the blog model and close it. So I will create a separate function for each request. Let's start by defining the create blog function first. It takes a request and response object. Let me navigate to index.js and cut this part as we don't directly code here anymore, and paste it inside the create blog function and add async here. Let me also create one more function for get blogs. So I will duplicate the create blog function and rename this to get blogs. Let's head to index.js again and cut this part of the function. Now let me paste it here and it should be fine. Great, it's time to export both the controller's functions, and it is best to export them as objects of functions so that we can import them by referring to their name. The next step is to replace the root callbacks with the controller we just created. So let me import the controllers. So add const and the object's destructuring keyword for create blog. And let me take get blogs from the controller, then add is equal to require, and pass the blog controller path. So let me replace this with the function I imported. Also, let me replace this with create blog. Now, let me add this to the controller since the database is moved there. It looks great, so let's run it and see how it goes. It seems we're having an error with the import. I need to correct the path to the model. It's now being imported from the controller directory, so it should be / and one directory back, and then model/blog.model. Let's run it again. The server is running fine now, so let's test it in Postman. And here I have created 2 requests for creating and getting blogs. Let's check the create blog API by setting the body to be a raw JSON. And let me paste a test data and send the request. Okay, we got a success message, and let's fetch it by sending a request to the blog URL. So it returns the blog we just created now. Let's confirm that by looking at the database itself. I'm using Studio 3T for MongoDB graphical user interface, and you can also use MongoDB Compass or anything that works for you. Now, we have a couple of APIs, but it will eventually grow, so we need to add that in a separate directory too. At this point, I think it's clear that the next step is creating a root directory, and let's add blog.root.js file to hold all the blog-related roots. So let's go to the index file and cut the roots and paste it here. I need to import the controllers as well, so I will cut the require statement from the index and paste it inside the blog root. Let me now import express. Const express is equal to require and pass to it express. So let's define a router variable and assign it to an express.router, which is an express function used to create routers or request paths. So here we can use the router we just created instead of app. Now let me export the router, and it will later be added to the Express main application and be accessed through the API. Let's go to the index.js file and import the router. Const router is equal with require and pass to it the router file, router/blog.root. So here, let's add the router to the app, and it will automatically add all the blog URLs to the server. Let's run the server and check if it's working as expected. So it's the same issue as before. I need to correct the controller path in the blog.root file by just moving one directory back. Let's clean up the terminal and run it again. It is now working great. Let's go back to the code editor. So we were able to clean it up, and we now have a better structure. In the next videos, we will keep adding more till we get an excellent architectural base. Configuration information such as database information, port number, API keys, or any variables that's common to the application shouldn't be mixed or stored in your source code. Instead, it should be separated into an independent configuration file and injected into the runtime environment. The benefit of keeping configuration settings separated from the application logic is that you can apply configuration settings according to the deployment path, so you can have different configuration settings value for a development, production, and test environment. It also makes it easy when you want to change the configuration value, since you can find it in one place instead of searching everywhere in the source code. So I'll create a .env file and store the port and database connection there. I'll use the .env package to load the environment variables from the .env file and access it using process.env. So let me copy the installation command and install it in the project. Next, let's create the .env file to store the configuration values. So instead of hard coding the database here, let me create a DB connection environment variable in the .env file. So let's give it a name of db_connection and assign it the DB connection URL. Since I stored it in the .env file, it's accessible via process.env.db connection. So next up is port. Let me cut this out and define it inside the .env file. Port equals to 3000. Let me go back to the index file and add process.env.port. Let's also update the console log to use the environment variable. And the single quotes should be replaced with backticks. So let's start the server. The .env library is missing, so I need to import it. Let me scroll up and add the require statement with .env, then call the config method on it. Let me run the server again. And it's not working. So calling config after requiring the .env will set up the configuration by reading variables from the .env file and adding it to the process.env. Since process.env is a global variable, it's accessible in the entire application. We've made one-step improvements by adding .env file, and we can even improve it more by adding a config directory and validating the environment variables. So let me add a directory called config and add a config.js file inside the config directory. Validating the environment variables is useful to make sure that we have the right settings and we haven't missed anything necessary to run the app correctly. I'm going to be using a library called Joy for the validation, and we'll also use it to validate the requested data. For example, here it's saying that the data should be an object consisting of properties such as username and password. And it further defines the object keys. For example, a username should be a string and only a letter and a number with a minimum of 3 characters, and so on. So after the schema is defined, it's calling the validate function to validate the data. If every condition is met, it will return the data itself, and if not, an error will be returned. So let me install it using npm ijoy. I need to first import the joy package, so const joy is equal to require and pass to it joy. Next, let me create a schema called invar schema using the joy.object function, and it takes an object that contains keys and their roles. Let me copy the db connection variable name from the .env file and paste it here. So db connection should be a type of joy string, and it's also required. Next, let's define the behaviors for the port. The port is a type of joy number, and it should be a positive number. And if the value is not provided, it has a default value of 3000. Let me call .unknown method to allow adding variables other than what is defined here. Now, let me validate the environment variable with the schema I just created. Let's define a const variable of value and error and get those values from invar schema.validate and pass process.env. I want the value to be returned as invars so that I can access it with invars later. So value and error are what's going to be returned from the schema.validate function, and we'll use invars to fetch the values. Let's check if we encounter any errors. If there's an error, for now, I will just console log the error itself. So the config is for validating and exposing configuration values, and we'll export the environment variables from here and use this config file to access them instead of fetching it from process.env. Module.exports is equal to an object containing the port, which is invars.port, and the db connection, which is invars.db connection. So let me take the .env require statement from the index file and paste it in the config.js. And let me import the config file here. So const config is equal to require and pass the path to the config file. So let's replace all the process.env values with values from the config. Here it should be config.port. Let me copy it and replace it here as well. Let's clean up the terminal and restart the server again. Perfect, it's working great, and we have taken our code base to the next level by adding configuration and validation. In the previous video, we added configuration and I showed you how we can validate environment variables. I added the validation inside the config.js file and it worked well. But what if our environment variables grow? Not only that, but also we need to do more validation for the data we take through requests. So it's best to separate it into an independent directory. So let me create a validation directory to hold all the validation files. Let's start by adding env.validation file. So I'll take the schema from config.js and add it to the env validation, then I'll export it. I'm going to copy and paste the schema definition to the env validation. I also need to export it. So module.export is equal to the environment variable schema. Next, inside the config.js file, we don't need this anymore here, and we can replace it with the schema imported from the env.validation. We also don't need the joy package here, so let me delete it and run the server again. Cool, it's working fine. So now let's head to the controller. Here, it's saving the blog without validating, and every data that comes from a user shouldn't be trusted and should be validated before it's saved. So let me create a new validation for it. Inside the validations directory, let's add blog.validation.js file. Here, let's define the schema to validate the incoming data for creating blog. So const create blog schema is equal to an object with attribute of body, since we are going to validate the body part of the incoming request. Let's not also forget to import the joy library. So the body is a joy object. And let's call the keys function to specify the body attributes that need to be validated. The first thing I want to add is the title, which is a type of joy string and required. Let's also add a description, which has the same type and validation as the title. And finally, let's export this schema as an object of functions. So you can add as much as schemas in this file and add it to exports. So now let's import it in the blog controller. So const blog schema is equal to, actually it's better to use the schema name itself, so I will copy this and paste it here. Then require and pass it the relative path to the blog.validations file. Let's wrap this with destructuring syntax, and here, before the create function, call create blog schema dot body dot validate async, and then pass the request body. So let me add a weight and assign it to a const variable of value, and change this to value. So what this does is validate the request body asynchronously, and if the data is valid, it returns the value, and if not, it will throw an error. Let me test it by sending an empty body. Okay, we got an unexpected error. Let's see what it's about. So here in the catch block, let me comment this out and console log the error to see the format of the error. So let me restart the server and send the request again. You can see here it's logging the validation error with details, and the format is a bit different. So let's change the error.message to error.details. So again, let me run the code and send the same request. Okay, we are still getting the same error. So here, it should be a response.send. Let's save the changes and restart the server again. It's returning the error now. We can obviously do some improvement on the error format, and I also want to add a separate middleware to take care of the validation. So let's do that in the next video. Middleware is something that acts as an intermediary between services or applications to facilitate their communication. In our server, middleware is an architectural entity that sits between the request and the controller. Instead of adding the validation on the controller, we'll create a separate middleware that sits between the request and the controller. The create block request needs to pass through the middleware before it gets to the controller. If only the data is valid, the create block function will be called. Let me create a middleware directory. And inside it, let me also create validate.js file. So let's define the validate function, which is an arrow function that takes a schema argument to validate the request with. Since this is a middleware, it takes a request, response, and next. If the request is valid, next will be called, which means it will call the create block function, and if not, it will respond with an error. Let's import the Joy library first, and I will define the keys that needs to be validated. So const keys is equal to an array that contains params, query, and body. So this middleware is going to be called on every controller that takes data. So it's kind of a general function that checks if the data passed to the controller is valid. The three keys, params, query, and body, are the attributes sent with any request, so we want to validate them. The request object contains not only these three keys, but also many other information. So let me pick only these three keys from the request. So const object is equal to keys.reduce and pass the object and key argument. I'm using the reduce function to loop through the keys, and it will reduce it to only those keys which have a value in the request object. So first, let's check if the request has a property of key by using the hasOwnProperty.call method and passing the request object and the key. Then let's assign object of key with request of key. So inside the reduce function, we added a condition to check if the request has a property of key, and if so, we'll add it to the accumulator object. And finally, we'll return the accumulator object, which contains only the key that have a value in the request object. Let's not forget to return the accumulator object here. So this way, we only pick those three keys, and if only they have a value on the request object. So now, let's validate the object. So const, and let's extract the value and error from joy.compile and pass the schema, then call .validate and pass to it the object. So I'm using joy.compile function to convert the schema definition to a convenient Joy schema object. Here's the advantage of a middleware. If there's an error, we can respond with an error before it gets to the controller. So I would like to format the errors in a more readable and easy format by looping through each error. And returning the key using detail.context_object and the error message using detail.message. Now, let's set the response status to be 400 and send an object with error flag set to true and contains the error list. So Joy returns the error containing details attribute, and the details attribute has keys, which are the field name and the error message. So we loop through the error details using .map and assign the errors variable a new formatted error. And then we responded with an error with a status code of 400, since it's an error caused by a user sending a wrong data. If there's no error, we'll simply call next, which in turn calls the controller function. Let's now export the validate middleware so that we can access it in the routes. Here, I forgot to add the second parameter, which is the initial value of the accumulator object, and it starts with an empty object. So let's head to the block controller and let me remove the validation from the controller, since we'll add the validator middleware. Let me get rid of the import statement too. So let's head to the blog route, since middlewares are added on the router. I will first import the create blog schema first from the blog.validation inside the validation directory. Let me also import the validate middleware function, which is defined in the validate.js file inside the middleware directory. So let's copy it and add it before the controller by passing the create block schema to validate the request with. So let's run and test it. Let me click on create blog request and add a raw JSON body for an empty object. Then let me hit on send. So you can see it's saying the title is required when sending an empty object. Let's also test it by adding a title with the value of number. It is now returning an error with a message, title must be a sting. So let's invalidate data and see what we get. So it's supposed to work now, but it's saying param is not allowed, which means that it's including param, even though param doesn't have a value, and we only want to validate the body. Let me see what the object has by console logging the object. Let's restart the server and send a request again. As you can see, it's including all the keys, even though they have no value. That's because the request object has always those keys, the param, body, query, even though no data is passed through them. So instead of hard coding the keys, I will replace it with the schema keys using object.keys and pass to it the schema. So object.keys returns the keys specified in the schema, which could be body, params, or query. Let's test it once again. And it's working perfectly. In this particular session, I will make some changes to the way we are handling errors. If you notice here on the block controller, we are using try catch repeatedly and responding to an error. Also, you can see that we're handling an error the same way on validate.js as well. This can get very repetitive when the project gets bigger, so I will create a separate error handler which can be plugged as a middleware. Inside the middleware's directory, let's create errors.js file. So const error handler is equal to an arrow function, which takes error request, response, and next parameters. And we expect to have a status code and a message from the error argument, which, by the way, is passed from whatever calls this middleware function. Now, let's define the response we are going to send. const response is equal to an object with an attribute of error set to true and error code set to the status code. And let's also add the error message. Now let's set the response status to the status code we just defined, and also send the response. Okay, so it's basically taking error and response, and it formats and sends it. I will also add an environment variable to differentiate the error handling for production and development, because in production, we don't want to expose any errors, and in development, we would like to see the errors. Inside the .env file, let's define node_env and set it to development since we are in development mode. Let's go to the config.js and export the environment variable I just created. So let me assign it to invars.node_env. Inside the errors.js, let's import the config. Const config is equal to require and pass the path of the config file. And the last data that we want to send is the error stack, which is the detailed information about the error. So I'm using the 3 dots or the spread operator to expand and add the stack to the object. So let's check if config.env is equal to development. That means we are in development mode. So let's add the double end operator and an object with stack set to error.stack. And how the AND operator works is it checks the first statement, and if it is only true, it will check the second statement. So if the environment is development, it will add the stack to the object. And if not, it won't even check the second statement because one false and any condition is false. So again, if the environment is development, let's console log the error. Now we can export the middleware so that we can access it from another file. Let's head to index.js and add it as a middleware. So I need to import it first. Error handler is equal to require and pass the path of the middleware file just as usual. So since we want to apply the error handler for every request, let me add it on the app. As always, app.use and pass the error handler middleware. Here, I will just call next with an error and a status code, so it will call the error handler. So whenever we pass an error to the next function, it will be handled by the error handler. So let's test it by sending a request with the wrong data. So set the format as JSON and send an empty data. We should have seen the error on the console. Let's see what went wrong. Okay, everything seems to be okay here. It looks good here too. Let's head to the env file. You can see that we have a spelling mistake here. For now, we are passing an object to the next function, but we can create a proper error class. So let me create a utils directory to create the error class. Inside it, let's add a file called api_error.js. And we'll be using the utils directory for functionalities that will be reused in different files. We are going to create a class here, and I'm assuming you have a basic understanding of OOP. So let's add class API error which extends the JavaScript error class so that we can use the property or function of the parent error class. Next, let's define the constructor and pass the status code, message, and is operational, which I will explain later, and the stack. Let me initiate this with true and call the super method with the error message. So a constructor is a special function that's automatically called when an object is created using the API error class. And it takes these 4 arguments such as the status code and error message. So calling super is like calling the constructor of the parent or the error class to assign the error message a value. Now, let's check if stack is provided and assign it as a stack property using this dot stack equals to the stack we get through the constructor. And if the stack is not provided, let's call error.capture stack trace to create a new stack that initiates from this API error class. A stack is nothing but a trace of which functions are called, the order, the line, and the files where the error was caused at. So the first argument is for which class we want to capture the stack trace, which is this class. And the second argument is where the stack trace should start, which is from this constructor. So this key refers to the API error class property. And let's assign this dot status code a value. And also, this dot is operational equals to the is operational of the constructor. I will explain the purpose of is operational, but for now, let's just export it. So it's taking the arguments through the constructor and it's assigning it to the class. Now, let me head to validate.js and use the API error class. Let's duplicate this line and replace the object with the API error class I just created. Before that, let me import it. Const API error is equal to the value we get from importing utils/API error. Perfect. Let me copy the API error and create a new instance of API error class and pass the status code a message. The other parameters are optional. Let's start the server again and send the same request, which carries an empty data. All right, we are now getting an error, including this stack, but this is just an object, so let's change it to a string. You can see that it's logging it here. To concatenate all the error message, let's add .join and pass a comma to separate each message. Okay, so this needs to be changed to just detail.message since we only need a list of messages separated with comma. Okay, let's run the server one more time and see if it is working as expected. It works great, and I will see you in the next session. In the previous video, we set up an error handler and we added it to the validation. In this video, we'll do a better approach to handle errors for the controllers. So here in the block controller, we can call next and it will call the error handler, but instead of doing that, I'm going to replace the try catch with something better. Inside the utils directory, let's create catchAsync.js file. And let's create a function here. Const catchAsync is equal to an arrow function, which returns another function. So the function takes a controller function as an argument, and also the controller function parameters, which are request, response, and next. So I'll now call the controller function and also handle the error if there's any. So let's call promise.resolve and call the controller function with request, response, and next. and add the catch method to catch any possible errors thrown from the controller function. So when there's an error, next is called with the error object. Let me export it and I will explain why I used promise. Promise.resolve resolves or returns the value returned from calling the controller function, fn, and if it has an error, we'll catch it here and call the next error handler. So now, in the controller, let's call the catchAsync by passing the controller function as a parameter. Let's cut this and paste it inside the catchAsync. Now we don't need the try catch, so let's get rid of it. Let me fix the brackets here. And I need to import the catchAsync here from the catchAsync file we created inside the utils directory. Let me also do the same for getBlocks by wrapping it with catchAsync. Okay, it's much better now, and we can use the catchAsync function on every controller. Hence, the controllers don't need to worry about handling errors. So now let's test it by calling the wrong function intentionally. Let me add one more E here, and let me restart the server and send a request. So what happened is whenever there is a server error, like calling the wrong function, the errors thrown have no format. That's because it's not intentionally called by the next function by passing the API error class we created. So in the next video, I'm going to create error converter to format unexpected errors to have the right standard or format. While developing the APIs, we should make sure that the error responses have the same format so that we can easily manipulate and use them in the front end. We've seen that errors can be initiated intentionally from the validate middleware whenever a user sends invalid data, and it can also be caused by syntax errors, such as when we misspell a function name or not follow JavaScript syntax rules. When any of those errors occurred, we called next by passing the error. It simply means call the next middleware. If the error passed doesn't have the right format, such as the status code, message, and stack, the error handler cannot do its job right. So I will create an additional middleware that sits before the error handler. Whenever next is called with an error, it gets to it first and it will make sure to format the error in the right way, and then it will call the error handler with a well-formatted error. Then the error handler can do its job without worrying about the wrong error format. Let's go to error.js file and define the error converter function. So it takes the same argument as the error handler. And let's add an if statement to check if the error is an instance of API error class. But I need to import it first. So const API error is equal to require and pass the path to API error class inside the utils directory. Let me now copy and paste this. If the error is not an instance of API error, we know that it's not intentionally thrown with next, so we will create a new API error. So let's define an error variable. Now let me replace this with the error I created. Inside the if condition, let me define the status code, which can be obtained from the error.statuscode. Or if the error is an instance of mongoose.error, I will assign it a status code of 400. Before that, let me correct this to just mongoose. So let me add here a question mark then 400, and if not, it will have a status of 500. So if error.status code has a value, it assigns it to the status code, and if not, it checks if the error is an instance of Mongoose error or thrown from MongoDB, and if yes, it assigns it 400 or bad request. And if it's not a Mongoose error, the status code will be 500, which means a server error. So instead of hard coding the status code, I'm going to be using HTTP status npm package that has all sorts of status code with its own error message. Let me install it using npm install http-status. Let me minimize the terminal to get more space, and let me require the HTTP status first. Let's copy this and find the status code. Here, replace it with http status.bad request. It's the same as saying 400. And this with http status.internal server error. You can see that it is now more readable. So let's define the error message here, and it has a value of error.message if it has a value. If not, we can generate a new message using the HTTP status package. And finally, let's create the error, which is an instance of API error, and pass the status code, message, false, and the error stack. We can now call next with the right error format by passing the error we just created. Let me now copy and export it here. If you remember, the API error class is operational property, and if it is true, it means that the error is a known runtime error, or it's anticipated, such as an error caused by an invalid user data. Here, we're passing false because the error wasn't an instance of API error class, or it wasn't thrown intentionally. Now, let's add the error converter to the app. Let's first import it by just adding error converter here. Make sure to add it before the error handler, and let me copy and paste it here. So now, let's run the server and test it by sending the same request. Okay, we now have the right formats. Let me go back and put this to the top. Now, let me add one more thing to the error handler, which is to check if config.env is equal to production and if the error is not operational. So if these two conditions are met, we don't want to expose anything. So the status code will be http status.internal server error. And the message will be a generic server error. Let's test it again. Okay, we have some error. Let's go back and see. So here, it shouldn't be const, so let me change it to let and save the changes and run the server once again. Okay, you can see that it's returning the message as expected. Finally, we want to store the error message in response.locals so that the front end will have access to the error message, but limited to a single request that caused the error. So res.locals is an object that is available for the entire lifecycle of a request. It serves as a storage space for data that needs to be shared across various middleware functions and eventually accessed by the final response handler. Okay, this is it for this video, and I will see you in the next one. This will be the last video on error handling, and I'm going to show you how to take your requests to unexisting paths, unhandled exception, and promise rejection. Let's open index.js file, and at the end of the routers, I will add another middleware, app.use, and pass it the middleware function. It takes request, response, and next, just as always. Inside the middleware, let's call the next function, but first I need to import the API error class so that we can pass it to the next function as the error argument. Let me also import HTTP status and assign it to import of the HTTP status package. Let's pass a new instance of API error with HTTP status of not found and a simple error message of not found error message. So this will call the error handler with this API error instance, and it should always be added after the route so that if the path is not found, it will directly go here. Otherwise, it will respond with not found for every route. Let me start the server and head to Postman and create a new tab. Now, let me enter an unknown path and test. It returned a 404 error, just as we wanted. So whenever there is an unhandled exception, the uncaught exception event is emitted, and we want to catch it by calling process.onUncaught exception and passing a callback. Let me define the callback function first with a name of unexpected error handler and assign it to an error function which expects an error argument. For now, let me just console log the error, and I will create an error logger in the future. Here, let me call an exit handler function, which I will create later to shut down the server gracefully. So let me copy the name and define the exit handler function here. If the server is open and running, we want to close it by calling server.close method, which takes a callback function. Inside it, let me console log the server is closed message, and below it, add process.exit and pass 1 to exit the process. Else, I will just exit the process. So now, let's pass the unexpected error handler function here. So whenever there is an uncaught exception, the unexpected error handler is called, and we log the error and call the exit handler function. So in the exit handler function, it's important to close the server if it's opened. And also, I called process.exit inside the close function because we need to make sure that we close the server before exiting the process. And process exit with code 1 indicates that the process exited because of failure. I want to also do the same for unhandled promise rejection, which occurs whenever a promise is rejected and it wasn't properly handled with some sort of catch block. It will keep us safe just in case it happens. So let's call process.onUnhandled rejection, and I will use the same function here. So let me run the server and see if everything works fine. Okay, it says cannot access unexpected error handler since I called it before it was defined. So I need to switch the functions order. So let me cut this out and paste it under the functions. And the exit handler function should be above the unexpected error handler function. Perfect. Let's run it once again. All right, looks great now, and I will see you in the next video. In the previous video, you've seen me constantly typing node index to start the app, but that's not obviously a great way to start the app. And in this video, we will see how to make it reload by itself whenever there is a change, and I will also clean up index.js. So we're going to use a tool like Nodemon, which automatically starts the server when we make a change to a file. Let's install it by running npm install Nodemon -save dev to indicate that it's development dependency since we are using it only in development. Let's open the package.json file to see if it is added. As you can see here, it's added as a development dependency. Now, I will add a script which is supposed to start the app. So let's add a new attribute called scripts, which contains a start command to run index.js using Nodemon. So this means whenever we run npm start, Nodemon runs index.js. Let's try it by running the command npm start. As you can see, Nodemon is watching for changes. Let's navigate to index.js. And there's a little mistake from the previous video here. I should have defined the server first. It was running okay because the exit handler is called only when there is an unhandled exception. So let me trigger an uncaught exception to demonstrate what I'm talking about. I can just remove the catchAsync here and give it unexisting model. Let's save the changes and head to the Postman to invoke the API. You can see the error server is not defined. So let's reset the file to where it was before. And let's head back to index.js. We can simply assign it to the server like this. But what's even better is to create HTTP server using the HTTP default module because it will be very easy to add HTTPS as well. Also, it would be very helpful when you are working with Socket. So let me import the HTTP module. We also saw about HTTP in first section. Let me scroll down and right below the middleware is where the app setup ends. I'm going to create the server using the HTTP module. Const HTTP server is equal to http.createServer and pass it the Express app. Now let me replace this with HTTP server. So this way, if you want to add another HTTPS connection, you can just import and add it. All right, so now I'm going to create a separate server.js file, which will only be responsible for the Express app, routers, and middlewares, and index.js will only be used to start and bootstrap what is needed to run the app, such as setting up the database, listening to the server, and exceptions. In the root directory, let's create a server.js file. I'll move anything that has something to do with the Express server. So let's start from the import statements and cut these 5 imports and paste it inside server.js. The app and Express are not supposed to be here, so let's cut and paste it there. Let's also take the middleware setup since it is related to the Express app. I think it's pretty much done. So let's go to server.js and export the Express app. Let's see if anything is left. So config should be in index.js file. And let me also import the app. Const app is equal to require and pass the path to the server.js file. As you can see, the implementation is much cleaner, and we created a separation of concern between starting the application and creating the server. Previously, we have seen how to close the server gracefully when there is an unhandled exception, and I also want to close the server when we close the Node.js process from the terminal, for example, by entering Control+C. So I'm going to listen to a sigterm event on the process module, which is fired when Control+C is detected on a Linux operating system. At the bottom of the index.js file, I will add the listener. So let's call process.on and pass sigterm and also the callback function. Inside it, let me add a simple console log statement with a message of sigterm received. Then let's check if the server is running. If so, call server.close function. So Control+C doesn't fire a sigterm event in Windows, but since the deployment server will probably be a Linux, I'm going to keep it like this. An application can have different messages, such as errors, warnings, information, and user interaction data. Logging errors and information can be very helpful to debug and monitor the application status. Previously, we were using console log for logging, and in this video, we'll do something more advanced to log information. So I'll be using an npm package called Winston to log the data, and it supports multiple transports or storage media to log the information. We can log data to the console file and the database. It also provides different logging mechanisms based on the environment the server is running on, so that we can log a detailed information in development and high detailed in production. Let me first install it using npm install Winston. Now, let me create a logger.js file in the config folder. Inside the logger file, let me import Winston and create a logger. Next, we need to create the logger. We can create a logger by using winston.createLogger, and it takes an object. Let's define the level first and assign it a value info. The level is used to indicate the type, importance, and severity of the log message. There are several levels from 0 to 6. 0 is for error, and 1 is for warning. 2 is for information, and 3 is for HTTP, and so on. Next, let's define the format, and it has a value of winston.format.json. Let's add transports, which expects a list of the transport medium where the data should be logged. For now, I will keep it simple to only log it to the console. At the end of the file, let's export the logger. Inside the index file, let me import the logger I just exported. Const logger is equal to require and pass the path to the logger file. So now let's replace the console log with the logger I imported and run the server to see if it's working as expected. It's being logged here, and if you notice, I called the logger with a level by saying logger.info, and you might ask why specify the level 2 times. That's because the level we defined when creating the logger is the maximum level we can use whenever we log a data. So it only log messages equal or below the info level, such as warning and error, and the level above info, such as debug, will be ignored. And here we're setting the level to be a specific log message, which is server listening to 3000 to be an informational log. So next, I want to change the log format. So let me create a custom log formatter here. I'm using Winston.format.printf function, which takes a callback function as an argument. So the callback takes an argument of an object with 4 properties: the level, message, timestamp, and stack. The callback returns a new format that has the level and add a colon to separate the parameters. Let me also copy the timestamp, and it should be in the first row. And let me put the level here. If there is a stack, the stack will be added to the log format. If not, we simply add the message. Instead of repeating the format and create logger function, I'll define it here once. So we can fetch the format and create logger function from Winston. Now let's remove Winston from both functions. Let me also change this to format.combine and pass format.timestamp and the Winston format I just created. Format.combine is a method used to combine multiple formatting functions into a single formatting function. And the format.timestamp adds a timestamp to each log message, and format.printf formats the log to include the log level and message. This is object destructuring, and to simplify it for you, let me put a single object argument here. Now I can take the values from the object and let me log it to see what it looks like. So you can see it's the same as before, and you can also see what the object contains. So this is it for this video. The architecture is getting better with each session, and I will see you in the next video. In this session, I want to add some configuration to set up things based on the environment the server is running. And let's start by importing the config from the config file in this directory. And here I will add one more option to define the log color based on the environment. So if config.env is development, add color to the log message, and otherwise we don't need any color. This is helpful to easily differentiate between development and production. I also want to check the environment here to set the level to debug or info based on the environment. Earlier, I mentioned that the level is the maximum level that the logger can log, and here I allow debugging information for development, but for production, I kept it to info because we don't need those debugging details. Now let's do some refactoring. Let me define this above, just like I did before. Next up, let me import functions from the format object. The first one is the printf function, and the second one is the combine function. Next, let's add the timestamp function. Let me also add the two color functions. So here we don't need the format object. It looks better now, and the next thing to do is to find all console log statements and replace it with the logger. So let's start by replacing this with logger.info. Here, let me replace it with logger.error since it's logging an error. Again, replace this with logger.info. Let me scroll up and do the same here. So let me find if any console log statement is left. Okay, it seems like we don't have any more console log statements. So now let's navigate to other folders. So let me import the logger from config/logger. Let me scroll down and replace this with logger.error. Let's also search in the entire project. We have one more console log here. So let's do the same by first importing the logger. Okay, let's replace this with the logger for the last time. So now let's see how it responds when there's an error. Let me just call unexisting function to test. Let me head to Postman and send a request. As you can see here, it's been logged with its stack. So let me remove this and this will be it for this session. In the previous video, we've seen how to create a logger, and in this video, we'll add Morgan to log HTTP requests, which is useful to monitor and analyze HTTP requests. So there are various information Morgan lets you store, such as the HTTP method, the IP address, the response time, the status code, and etc. I will use a file to store the logs, and let me install it. Let me stop the server and run the npm install Morgan. Inside the config directory, let me create morgan.js. So let me first import Morgan by simply requiring the Morgan package I just installed. And call Morgan and pass combined, which is a log format, and export it. Here, we specified the format combined, which means the combination of all the HTTP request information. So it can be as simple as calling Morgan with the format, then you can just add it as middleware. You can also use other formats like tiny, short, and div. All of them return information about the request. Now, let's add it as a middleware to the Express server. So let's first import Morgan. Here, it is not the Morgan package, it's the Morgan file I was just working on. So let me copy it and add app.use and pass Morgan. Now let's start the server and test. Okay, we got our response. Let's go back and see the changes. Here, you can see Morgan logging the request information to the default transport, which is the console. We have the date, the HTTP method, the URL path, the HTTP version, the status code, the time it took, and the user agent, which is the software used to send the request, and here it's Postman. So now let's log it to a file so that we keep the information. So to store the logs in a file, I need to import the fs module and also the path to work with the file path, such as figuring out the absolute path. Next, let me define the access log stream and assign it to fs.createWriteStream, which takes the file path using path.join and pass the directory name and the file name, which is access.log. Let me create a log folder for it, and I will update the path. So add /logs here. Let me save the changes and open the terminal. Looks like the server crashed, but let me explain first before fixing the error. I imported the fs file system module and the path module to create a writable stream. So it stores the data piece by piece instead of storing the whole data at once. And the createWriteStream function creates a stream to write to and takes a path to a file. So I used path.join to find the absolute path of the access log file by joining the source directory to the file. The error is caused because the file path is wrong, so I need to go back one directory because we are working on the config folder. And to find the logs folder, we need to be out of the config folder. So Morgan has an option of a stream, and I just assigned it the stream I created. Let's test it, and you can send any type of request. Let me head to the access log file, and here you can see that it is being logged correctly. So now let's customize the format. I'm going to define a function called getIPFormat, which is an arrow function that returns the IP address based on the environment. So if it is in production, add the IP address, otherwise we don't need it. So :remote address is the IP address value, and I added a hyphen to differentiate it from the other information. Now let me import config, and I'll create the rest of the format. So const format is equal to a string that lists all the formatting info, and it starts with the IP address. So let me copy and paste this. Let me also add the method by using column method and the URL, the status, the response time, which is in milliseconds, the user agent, and the date. So let me use the format I just created instead of the generic one. One more thing I want to add is a flag, and when the flag is set to A, it tells the stream to append instead of overwriting. This is what we have now, a well-formatted log, and if I run it again in the background, you can see that it's appending instead of overwriting. In the previous video, I added the request logger, and in this video, I will create two separate loggers for error and successful responses. So here, I will create two more Morgan formats, and let me replace this with a success response format. Let me also move this to a new variable. Let's give it a name of success handler and paste Morgan here. Let me copy success response format and add it here. Now, let me export the success response format. Let me also create a new Morgan format for the error responses. So for the requests with error response, it's going to be a little different since I want to add the error message. Let me change this to error and replace this with error response format. So the error message is not by default there in Morgan, but we can create a customized error messaging by using morgan.token and pass the parameter you want to add to the log and a callback function that takes two parameters, request and response. So the callback function should return the value of the message, which is the error message stored in the response.locals. So return response.locals dot error message if it exists, otherwise return an empty string. If you remember here in the error handler, I saved the data on response.locals and I am using that now. Here, Morgan.token lets us add a new item to the log, which is the error message. So we can use it here using :message, and it will add it to the format. We can now export the error handler. Let me add a skip option here to skip responses with a status code of 400 and above, which is the error responses so that we only log the successful requests. So it takes request and response arguments, and it returns response.status greater or equal to 400. Let's do the same for the error response format, except it skips the successful responses. Okay, let me add both the error and success format handlers as a middleware. So let me replace this with success handler and copy and paste it so that I can also add the error handler. Looks like we got an error. Let me see. So it says error handler is already declared. So let me just import Morgan. And refer both handlers using Morgan. Cool, it's working now. Let me head to Postman and let's send a request with an unexisting path and another one with the path that exists. You can see here error message : not found and error message : blank. That's because there's something wrong with the skip function. Here, it should be response.status code instead of just status. Let me send a successful request in the background. And here it is, no more blank errors. I think we are done with topics related to logging. I am sure you have learned so much and see you in the next video. So here in the controller, we are storing our business logic such as interacting with the database and handling express requests. And that's mixing the actual task with handling requests. So instead of putting everything in the controller, I'll create services to separate the business logic while the controller is used for accessing services and responding to requests. So separating it not only creates a separation of concern, but it also makes testing way easier. So let me create a service folder in the root directory. And inside it, create a blog.services.js file. And let me copy everything from here. So here in the service, let's remove everything that has to do with express request and response. Let's correct the name here. So the same applies to get blogs, remove catchAsync and the express response. Let me head to the controller and import it. So const blog service is equal to require and pass the path to the blog service file. So instead of directly interacting with the database, we can use the service to take care of that. Let me fix the spelling here. I also want to add a response status. So let me import the HTTP status package. So let's add a status and pass HTTP status dot created, which is 201, and it indicates the creation of data. Let me also do the same here. Call blog service dot get blogs and pass the request body. Then add a response status of HTTP status dot OK, which is 200. So let's get back to the service and return the blogs. We don't need the request and response body anymore. So the create blog service takes the request body, and let me paste it here as well. Let's now test it by sending a request to get blogs. Okay, it is working as expected. So let me go back and remove this as we don't need it in the controller anymore. So the implementation details are taken care of in the services, and we don't write any code in the controller except for calling the services method and responding. Now, I want to improve how we require modules. So let me create an index file on every directory, and I'll export the functions from there. Let's start with the services directory, and inside it, create an index.js file. So now let me export the blog service, since that is the only file we got in the same directory. Let me go ahead to the controller and change the import. Here, I only need to pass the services folder, and it will by default import index.js inside the services folder. Let me close these files, and I will do the same for the controller's directory. And export the blog controller here the same way I did for the blog service. Let's create an index file for the models directory as well. And I will be doing that for every directories in the project. Module.export.blogModel is equal to require, and pass it the path to the model. Let me head to the blog service and copy the model name. So this should just be blog. Let's switch to the blog.service and update the import statement to just the models directory. Let's close all the opened files. In the validation directory, let's also add index.js. And as usual, module.exports.blog validation is equal to require, and pass it blog.validation. Let's add one more export for the env validation and assign it to require and pass the env.validation. Let me now change how we import the validation inside the other files. Here in the blog routes file, let's change this to blog validation from the validations folder. And call create blog schema by referring to the blog validation. Next, inside the config.js, we need to update the env schema with env validation, which is imported from the validations directory. So let's replace this with env validation and save the changes. Let's head to the blog route and apply similar changes by replacing this with blog controller, which is imported from controllers. And call the methods by using it. So this is all about creating services and enhancing the imports. And we got ourselves a bulletproof boilerplate to bootstrap any project.